Hi, I'm Il-Hun Yoon from Yonsei University, Seoul, South Korea, and I'll be presenting Enhancing Source-Free Domain Adaptive Object Detection with Low-Confidence Pseudo-Label Distillation. Previous domain adaptive object detection works utilize these labeled source domain data and unlabeled target domain data for the domain adaptation. However, source-free domain adaptive object detection adapts to a new domain using the model trained with the source data and the unlabeled target domain images as can be seen on the figure here. A previous source-free domain adaptive object detection utilizes the teacher-student network, labels with strong augmented image, and teacher model is updated by the EMA of the student model. There are limitations on high-confidence pseudo-labels. Difficult objects such as minor objects from minor classes or small objects are missed in high-confidence pseudo-labels. And although these objects may have higher confidence values as training continues, most of them do not have confidence high enough to be used as pseudo-labels. And this can be seen on the figures below. The source trained model and mean teacher, they all have a lot of proposals with low confidence values and high IOU with GT. However, our method effectively deals with these limitations and has a less number of low confidence objects with high IOU with GT. So we propose the low confidence pseudo label distillation. First of all, high confidence pseudo labels are extracted through conventional thresholding method using confidence values. And the first thing we do is to remove the proposals that are highly overlapping with high confidence pseudo labels. And then we remove the proposals with excessively high background score, such as 0.95, 0.99. The background logic is removed from proposals and softmax is applied. And proposals with low entropy after background score removal are chosen as low confidence pseudo labels. And for the cosine distance on the feature map between teacher and student model at the low confidence pseudo label is utilized as adaptive rate. And the final loss is the KL divergence between the class predictions of the teacher student at the low confidence pseudo label region along with the adaptive rate. Our experiment settings are as follows. We utilize the faster RCNN with ResNet 50 and VGG16 backbone as used by previous methods. And we utilize the data sets as follows. Cityscapes to foggy cityscapes, which simulates the weather changes. And Sim10K to cityscapes, which simulates the domain shift between simulation dataset to real-world dataset. And the KT to cityscapes, which simulates the visual difference between the datasets on the similar scene. And Pascal VOC to clip art and Pascal VOC to watercolor, simulating the domain shift between realistic dataset to artistic dataset. We performed the experiment on cityscapes to foggy cityscapes using both the ResNet 50 and VGG16 backbones because some of the methods utilize the ResNet 50 and some of the other methods utilize the VGG16. And on both backbones, our method had a high MAP with 40.4 and 40.9. We also performed experiments on Sim10K to cityscapes and Kitty to cityscapes. On Sim10K to cityscapes, we had the MAP of 49.4 on the car, and we had the AP of 51.3 on the car at the Kitty to Cityscapes. And we also present the result on Pascal VOC to clip art and Pascal VOC to watercolor. And our method shows the highest MAP among the other SFOD methods, as you can see here, with 34.0 MAP on Pascal VOC to clip art and 55.2 on the Pascal VOC to watercolor. And for more details such as ablation studies, qualitative results, and pseudocodes, please refer to the link below. And if you have any more questions, please ask us through the email on the first page. Thank you.